Is there a difference between mass and weight? Do they actually mean the same thing? Okay, now let's be honest with ourselves. They are actually not the same thing. But this happens to be a case of confusion when it comes to individuals using it, and sometimes students get it mixed up where they use it interchangeably, and we are about to clarify that in the course of this video. Yes, my name is Miracle, and you're welcome to my channel, and this is actually the channel that is designed to educate you in every way possible. So let's actually start. So what's the difference between mass and weight? Now let's start. Mass is actually the measure. Let's use the word measure. Yes, it's actually the measure of the amount of matter that is present in a particular object or substance. Now, but when it comes to weight, weight is not the measure of the amount of substance. It is actually the measure of the gravitational pull that the Earth, yes, the Earth actually has towards an object, or the gravitational pull that the Earth actually have or exerts on an object. So, based on this, does that still give the total distinguishing features between mass and weight? There are so many. Now we can actually analyze the differences not just on definition, based on the type of quantity they are, based on the type of instruments used to measure them, and based on the variability, based on their denotations. Now let's analyze it based on all these things I said. Now when it comes to quantity, where do we classify the quantity called mass? Mass is actually classified as what we call some call it a base quantity, some call it a fundamental quantity. It is a fundamental quantity. It is based from mass that other quantities can be derived from. So yes, we call it a fundamental quantity or a base quantity. It is also said to be a scalar quantity. That means it has magnitude, it can be measured, it has a unit attached to it, but it has no direction. Mass is just on its own, it has no sense of direction. But when it comes to weight, weight is said to be something that is derived. It is not a fundamental quantity, it is actually derived, and not just derived, it is derived, and also it is said to be a vector quantity. Yes, weight is actually a vector. Now let's talk about the variability of these two quantities. When it comes to variability, now mass is actually going to be the same everywhere. Anywhere you go in the universe, it is going to have the same unit. It doesn't change any part of the world you go to. Yes, because we are just measuring the amount of matter that it possesses, that a particular substance possesses. But when it comes to weight, because of it is dependent on the gravitational pull of the Earth, bearing in mind that the Earth is said to be an uneven sphere. So that means gravity is actually going to be different at different points of the world, and because of it's going to be different, weight is going to be variable. And let's even leave the Earth, let's go to space, let's go to the moon, let's go to different parts of the universe. Now for example, in space there is little or no gravity, and when you go to maybe the moon, the gravity that's in the moon is actually different from that of the Earth. For that reason, the weight of any particular substance would actually vary. It is not going to be the same on any part. Hence, weight varies, and bear in mind that weight have the tendency of even having a zero. Yes, weight can be zero, especially in space. Space where you have little or no gravity, and bear in mind that the formula for weight is given as W is equals to mg. So when your g is actually zero, that means that whatever your mass is, if you multiply that figure times 0, it will still give you 0. But for your mass, it is not variable, so it is going to be constant. Mass is always constant, but weight is not constant. That's one thing you should know. And let's talk about the units at which we use to measure these things. Now when it comes to the units, for mass has the unit as kilograms. We can use the unit grams, milligrams, tons, pounds, whatever you work with. Now these are the units, but you can't use these units to measure weight, because weight is actually measured in Newton because it is a force. It is a force. So because of it is a force, we measure it in Newton. So you can even see that in terms of their units, they are still not classified in the same way. Now, apart from mass and weight having different units, what about the instruments we use to measure them? Now, when it comes to the instruments we use to measure them, for the instruments for mass, we have it to be given. What do we use to measure mass? Beam balance. We have the beam balance. We have the scale balance. Those things are used to measure mass. But when it comes to our weight, we use what we call the spring balance. So the spring balance is actually used to measure weight and not used to measure mass. Let's get that in our head. Now, one more thing we should bear in mind is this: that when it comes to yes, the dependency of I still said it initially, the dependency of variability. For mass, it depends on nothing to get its figure, it's just the amount. But when it comes to the amount of matter that is present in it, but when it comes to weight, a weight needs mass. You need to get your mass before you can actually get the weight. So for example, if our g happens to be 10 meter per second square and our mass happens to be maybe also 10, then we can say that our weight is actually given as 10 times 10, which is 100 meters. So there is always a difference between weight and mass. In terms of representation, our mass is represented as m. If you want to carry out your representation, especially in physics, it is represented as m. But if you want to represent weight, it is actually represented as w, the letter w. So remember, as I said, the formula for weight is w is equals to mg, and our m is just m, So you can actually still find your mass anyway with your with the formula. So for example, if you have your w is equals to mg, you can actually make your m the subject of the formula, and you divide both sides by g, and you have the m is equals to w over g. Yeah. So please bear in mind that our g is our acceleration due to gravity. So yes, by reason of this, I hope you understand that there is actually a difference between mass and weight. I know one way or the other you've been enlightened through this video, and I am hoping that you would appreciate this by giving it a thumbs up, which is the like. Please do subscribe for better informative content. So yes, it is still a growing channel, so please support it in every way possible, and you can even share it to individuals that you feel that might need information. Thank you very much, and it's been an honor serving you. So see you in my next video. Thank you very much.